Welcome to stats. We're going to look a little bit more at using standard normal to answer some questions for you. Namely, we're going to look at the cumulative effects of the standard normal curve. Namely, that one of the big ideas that we're going to look at in this particular instance is we know that if we have a standard normal curve, it looks something like this, and we want to know a particular spot right here. We want to know how much of the information is there. We have this thing that we can use. We can use some computer systems or some calculator systems that allow us to find it, but we can also use a table, and the table is really easy and accessible, and it doesn't require a whole lot of technical know-how in order to work it. No extra knowing of any steps for a calculator, what buttons to push and all that. So let's just say that we know this spot right here. We know whatever this z value is, and let's just say this z value is some quantity, right? And it's not necessarily 1 or 2 or 3, it's somewhere in between. Well, we can actually figure out, and this is the other advantage of using standard normal as opposed to just a standard curve, is it allows us to be able to figure out more about where that particular value is. So in a previous example, I looked at the idea of heights, and one of those height values was negative 1.7. So let's just say that this is negative 1 point, or I guess it was 5.7 or something like that, or 1.5 was the value. And we want to know, what does that mean? Where does that really fit in with everything else? What percentage are we dealing with? Well, we actually have ways of dealing with that. Namely, we have this table that allows us to be able to figure this up. So we're saying how much is below this, or maybe we want to figure out how much is above this. Well, we can do this the exact same way. What we do is we find out how much is below, the cumulative amount that is below there, based upon this value of being negative 1.57. And so that's what we're going to be looking at. But in this particular example, I'm going to actually I'm going to look at some other values here, and we're going to look at and saying we want to know if we have a score. Now let's say SAT score. Let's say we have an SAT score of 900, right? And this is the value that we're concerned with. And the question, though, is how many people in a particular event, or the particular people taking the test, scored 900 or better. So we're actually saying X is equal to or greater than 900. Okay, so how do we answer that? Well, that's not, we don't even know where this is on this little standard normal curve over here. So how do we figure that up? Well, remember, you can do anything you want to as long as you do it to both sides of the inequality, and you will maintain the inequality as it was before. So what I'm going to do here is I'm going to do x minus mu on both sides, right? X minus mu, all right? And then I'm also going to go through and divide by standard deviation on both sides. Well, guess what? Now I'm talking about having a z-score, right? So now I can just go through. If I know what the mean is, and I know what the standard deviation is, I can subtract the standard deviation, or I can subtract the mean from both sides. I can divide by the standard deviation on both sides, and I will have z is greater than or equal to this, right? And now I have the ability to talk about that in a little more detail. It's because I already have the x value up here, right? So, and this of course would be my generic version. This would be the actual value I would have, where I have x as the variable and I have 900 as that value right there. So all we need is the mean, which in this case, let's say the mean is 1010 or 1010, which if we were to look that up, I'm not sure exactly what the average ACT score is right now, but I think that's pretty close to what it currently is. And then we find that the standard deviation is 218. So what we then do is we just say, well, we're going to be looking to find that z-score there, and then we're going to say that's 900 minus 1010 divided by 218. That means that we end up with a z value. It's going to be negative. In this instance, it ends up being negative 0.50. Now, before I told you on another video that make sure you write this out 2 decimal places, because that ends up being a rather big deal to us. It ends up being important. So this is where this ends up being important to us. Okay, what I did is I went and grabbed this sheet here. This is actually a image from a z table, okay, a z chart, however you want to describe that. And the first, these columns all right, are different values. So we have the first value right here of point, you'll see right here we have 0.5 right here, negative 0.05. And then if you had additional values, you just go out further and further and further across based upon what values you needed. Now, it goes over to 0.09, okay, is what we'd add on, which takes us down to the next row. If you count this out, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we'd start over again with the next piece. So what we're saying, this would be 0.50, 0.51, 0.52, 0.53, 0.454, all the way down to 0.59, and then you're to 0.4, or I guess actually you go up the other way, 0.6 right there to the next value. Okay, so what we now have is a way to identify what this means. So if we look here, there's what we're dealing with. Now, what does that number mean? It means that, let's come over here to this thing. Here is mu equal to 0, right? So we're essentially talking about half a standard deviation. So here is 1 standard deviation over here. Z equal to negative 1. Here's where we are right now with z equal to negative 0.5. Okay, so what we now have is that this value that we just found here, this 0.358, that is the cumulative total of everything below that spot. Now these tables are built, some are built with a cumulative above and cumulative below. You really only need one, because if you can figure out one, you can figure out the other. So for this one, this was from below, from the left. So this is the cumulative effect up to 0.5, and the table actually goes all the way up, all the way across to 3.4, and at that point you're talking about 99.9% of the population of whatever you're looking at that point in terms of z-scores. So what we have over here is everything else, right? So the entire thing, all this is 1, okay, or 100%, right? Which we normally write would be 1.00, which means that this value right here of 0.3085, that means that we are from here to here. This is 0.3085, or 30.85% of the population. And then this over here is really what we're worried about in this instance, because we want to know that what percentage of the people have a 900 or better on the score. Well, this is how many people have a 900 or less. So what we would do is 1 minus 0.3085, which gives us 0.6915, or 69.15% of the population. So roughly 70%, almost 70%, 69.15% of the population scored a 900 or better on the ACT, according to this information here. And really all we did there, once again, was we took that value, we converted it into a z-score by subtracting the mean from both sides and dividing by the standard deviation. That gave us that z value of negative 0.5. We looked at our table where negative 0.5 was, and we matched that up. So if it was 0.51, we would have used 0.3050, or across the line there. And I'll work another example here in another video. But then we take that value, and that's 0.3. And since we want greater than that, and what that does is it gives us below that, it gives us less than that, we just do 1 minus that 0.3085 to find out how much is above that. So that means that this up here, this region up here, is 69.15%. This region down here, to the left, I guess I shouldn't say down here, is 30.85% of the population. All right, so I'll create some more videos with at least one more example with this and post it. And if you have more questions, or you want to see additional problems like this worked out, please let me know, and I'll see what I can post up. Have a great day. Take care.